Hey everyone, welcome back to the channel. So today we are exploring the Python sets. So in this video, we'll dive deep into sets, understanding their unique properties, advanced use cases, and how to leverage them efficiently in your Python projects. First, let's quickly review what Python set is. So a set is unordered collection of a unique elements. So unlike list and tuples, set do not allow duplicate values. So they are unchangeable and they are unordered. So these are the main property of sets. Here we have a set containing the integers. Notice that the order of the set is not guaranteed. So if I just click, it gives me the correct 1, 2, 3, 4. But let's mix some data into it. Now I'm just putting the string, the float value, and it gives the correct value. You can also create set using the set constructor. So you can put set and give the values in it. And notice I have giving you some duplicate values here. So it is 1, 2, 3. And as you know, set is on order. It does not allow duplicate. And it will give me 1, 2, 3, 4, 5. To show the unordered part of it, let's in case if you try to access the element of the set like you do in the case of list, by putting the index, it will give you throw an error, and the error is set object is not subscriptable. Also, sets are immutable; they cannot change, but you can add and remove. So in this case, let's me add the 5. So in this case, my set all right now contains 2, 4, 1, 3, and if I add 5, it will give me the 5. To remove the element from the set, we just use a remove functionality, remove function like this. And now 3 is gone. Let's talk about some of the mathematical set theory here. So Pythons are powerful, but they support several operations derived from the set theory. And let's look at some of the commonly used operation. So first, let's create two sets, set 1 and set 2, right? And use the union. So union is, it will remove the duplicates like in 1, 2, 3, 3, 4, 5. So 3 is 2 times here, right? So it in the set it has removed it, the duplicate value, and give it the 1, 2, 3, 4, 5 as the output. Intersection is nothing but it will give you the common value between these two sets, and the common value in this set is what? It's 3. If I run this, we should get output as 3. Now the next part is the difference between two sets. So different return element in the first set that are not in the second. So if we see set 1 and 2, what we have 1 and 2, which are not part of the set 2, but 3 is part. So we should get 1 and 2. And the next was is the symmetric difference. So it gives us the element that are either of the sets, but not in both. So in this 3 will be removed and we'll have 1, 2, 4, 5. Sets comes with a variety of built-in methods for modification and query. So uh, to let's create one set and let add and remove, which you have already seen. So in this case, we are adding 4 and we are removing 2. So the final is 1, 3, 4. Next is the discard. So discard and what is that is it's discard an element means it does not raise an error if the element is not found. So my set discard no errors, even though if I run this, even though 5 is not there, it has not thrown any error. Next is the clear and copy. So if you run using your set, if you use the function clear, it will empty the set, and if you try to empty for copy, it will copy a set. In this case, we are emptying and copy, so we should get empty set as the output, right? So there is no elements in this set. Next is the set comprehension. So they are another advanced feature. Similar to list comprehension, they allow us to create set consciously using the single code line of a code. So for example, I'm creating a set of squared value till 10. Uh, Time means 0 to 9. And as you can see, we are squaring the each element, and this is the result. So we created a set of square using a set comprehension. Is a compact and expressive way to build the sets. Also, to talk about the performance consideration with sets, so sets are implemented as a hash table, meaning that the average time complexity for operation like add, remove, and checking membership in is omega 1. So this makes sets highly efficient for operations that require frequent lookups. Some of two example of the practical application of sets. So in this case, let's say you want to eliminate the duplicate value from a list. So we created one list here and created a set of that data, and we should not to get any duplicate value in the unique data. And the final one is the checking the membership. So we can also, so if 3 is in the unique data, which is true, so we should print this line, 3 is in the sets. So to summarize, Python sets are versatile and effective tools for managing unique collection of data. And we have covered their creation, key properties, operation, and advanced feature like comprehension and some of the practical application. So if you found this video helpful, don't forget to like. Thank you for watching, and I will see you in the next one.